In this video, we'll continue our discussion of partial derivatives, but we're going to talk about what it looks like to go up with our derivatives, higher derivatives. What does it look like if I take multiple derivatives? But we actually have choices for this. Okay, so if I were given a function x of z made up of x and y, I have choices. Okay, I could take my partial of f with respect to x, but I also could take my partial of f with respect to y. From there, those are my first derivatives. I could take another derivative. The first thing I could do is I could just take the derivative again of the same variable. And that looks just like we wrote it in Calc 1. The second derivative looks like that. Another way to write this is we could say fxx. We also could say zxx. Now, that's not too confusing. The next part is pretty confusing. The derivative, partial derivative of f, we took x first, and then now above was xx. Now we're doing xy. How this looks, it's a little confusing, but we put our y first. The reason this is it's looked at like this. I take my partial of f with respect to x. That was the first thing I did, right? That's what this was. Then I took the partial with respect to y. The way that works out is exactly that above. This, now, to be even more annoying, we write it that way, but when we write our f with the subscripts, we put x first and then y. So, this is how I keep this straight. This one, it's the one closest first. That's what I do first. I do x first because it's the closest to the f, and that's the same thing here too. When I write it that way, x is the closest to f, so that's the one I do first. That's how I keep it straight. I know it's not ideal. I wish they would have, work together with notation, but this is what math looks like when all this stuff is being discovered at different parts of the world. Okay, so we have that. This is also equal to z, x, y. So x is first in that case. And then we have down here, taking the y first. Okay, well, I got squared, taking y twice, which is the same thing as fyy, and zyy. Then I could also have done x first and then done y. Or sorry, we did y first in this case. Forgive me. We did y first, then x. That's the same thing as fyx or zyx. So you just have to get that stuff straight. The confusing part will be this and this, right? And this and this. You just got to get them straight that it's the first one is the one closest to the f. All right, let's get an example of running through these, and then there's an observation that I really want to make given this next example. Okay, so we want to find each one of these. Notice those are my four. What these are called, these two things, I forgot to mention this up here. This and this are called mixed partials. Right? They're partials, and then the mixed part being x and y. Okay, those are called mixed partials. So we need to find the double derivatives here and the mixed partial. So we have to begin with just finding dx dy. So dz, oops, jump back in there, sorry guys. All right, dz dx first, right? Thankfully this is just a polynomial. So, okay, the 3 comes down. I got 9x squared y squared. I just leave the y squared alone. Minus, okay, I got an x there, so that just goes away, leaving the constant. X goes to a 1, plus 3xy goes to a 3y, and then the minus 3 is a constant, so it goes away. All right, we can do a couple things from here. Let's go ahead and do our second partial with respect to x. I got 18x y squared, and then I have the remaining are constants with respect to x. Okay, that is that. Let's go ahead and find dz, the squared, and then dy dx. So we did x first, now we're going to do y. So I got 18, that's looking here. We got the 2 comes down from the y, 18x squared y minus 3y squared plus 3. The constant, the 1 is gone. Everything else follows normal derivative rules. So there's my mixed partial. I'm going to write it out like this, x, y. Right? And then we did everything for that. Now let's start over with the y. So looking at our function above, we're back here. All right, the 2 on the y comes down. I got 6x cubed y minus 3xy squared. The x is a constant. This x is a constant, it's gone. And then we're left with 3x, and then the minus 3 goes away. There is my first partial with respect to y. Let's go ahead and do our double for that. So it's just y again. So x cubed minus 6xy, and then 3x doesn't have a y, so it's gone. And then we're going to do our partial. Y was first, that's above. So we're looking here right now. I'm going to take the derivative with respect to x. So we get 18x squared y minus we got minus 3y squared, that's the constant left, and then plus 3. Notice that this is 3yx. The observation I want you to make here is look there and look there. As long as our functions are continuous, I believe it's continuous, then our mixed partials will be the same. So for the most part, anytime you find mixed partials, they're going to be the same exact function. So that means on this problem, if I asked you on a test to find all of this, you don't need to do this work again in your head. Just write it down. It's the exact same thing. We know that. All right, so those are our mixed partials. Again, it's just the partial stuff that's going to take some work.